Alright guys, this is part 2 of your homework help video where I walk through 2 more sample problems. Again, they are similar to the problems that you have on your worksheet, but they are slightly different because I'm not doing your homework for you, okay? So let's take a look at number 2. If one wanted to produce, now that's from your homework, so let me change this to 43.7. If one wanted to produce 43.7 grams of pure silver metal, how many grams of copper will they need to react? So first things first, we have to balance this equation. All right, now I see 2 nitrates over here, and I see only 1 nitrate over here, so I'm going to put a 2 in front. Okay. Oh, and now I got 2 silvers, so I got to put a 2 here to balance the silvers. So 1, 2, 2, 1. Okay, so let's take a look. First step, we have to convert our starting amount into moles. So our starting amount is 43.7 grams of silver. All right, that's what we're starting with. Now, it's also worthwhile, here to take a look and see what we're ending with. Grams of copper is what we are ending with here. So I'm going to go down here, I'm going to jump to the end, and I'm going to put grams copper. Again, we're following a roadmap here, a pathway that'll tell us which 3 problems we have to do. So in order to properly follow this roadmap here, we need to know where we're starting and where we're ending. We are going from grams of silver into grams of copper. We can't do that in one step. It has to be 3 steps. And our first step is convert grams of silver into moles of silver. All right, moles of silver. Now, if you're going from grams into moles, you are going to use the molar mass, okay? If liters doesn't pop up at all, you're not using 22.4. 22.4 is for liter conversions. This is a gram conversion. So P table. What is the molar mass of pure silver? 107.87. That's great. All right, so I'm going to divide by 107.87. So 43.7 divided by 107.87. If this is a fraction here, then 107.87 grams per mole, that'll go on the bottom. Okay, so what do we get? We get 0.405 moles of silver. All right, that's how many moles of silver this is. Our next step is to get from moles of silver into moles of copper. But Mr. Gucci, it wants grams of copper. Again, we can't go there in one step. We got to follow the roadmap. We're getting out of moles of silver into moles of copper, all right? We got our starting mass into moles, then moles of A to moles of B, then moles of B into our final answer. You can't just jump over this, okay? There's no shortcut. There's no wormhole here, all right? So we want to get out of moles of silver, so moles of silver goes on the bottom. We want to get into moles of copper, so moles of copper goes on top. Okay, moles of copper goes on top. Now, we got to put these numbers in here from the balanced equation. The number that goes with the copper is 1. All right, 1, because that is the coefficient of copper from the balanced equation. And for silver, it's going to be 2, because the coefficient for the silver is 2. For every 1 copper consumed, we produce 2 silvers. So 1 copper gets us 2 silvers. So we're taking 0.405 and we're multiplying it by 1/2. All right? We're multiplying it by 1/2, aka we're dividing it by 2. All right? And so the answer is 0.203 moles of copper. Okay, that's half. I rounded it. All right, so there we go. So from moles of silver into moles of copper. Okay, now the next step, we have to take our moles of copper and convert it into grams of copper. We're going from moles into grams. If we look at the mole roadmap here, going from moles into grams, all right, we're going to be multiplying by the molar mass, okay? So we're going to multiply by the molar mass. The molar mass of copper is, 63.55. 63.55. So times 63.55. All right. So notice that 22.4 didn't factor in here at all. And the reason for that is simple. It's just that we didn't have to convert into or out of liters here. This was all moles. And sometimes you'll end up with problems that are all liter conversions, and you won't need molar masses. Sometimes you'll need both. You just got to follow what units they're giving. So 2.03 times 63.55, and I got 12.9 grams of copper. Okay, so if we want to produce 43.7 grams of silver here, we need to consume 12.9 grams of copper. Okay, that's the final answer. Again, we had to figure out, well, if it's grams of silver, how many moles of silver is that? And then we had to figure out, well, if it's that many moles of silver, how many moles of copper will we consume? And then we took that moles of copper and we turned it into a gram weighable amount that we could actually weigh out and put into a beaker. Okay, here we go. Last sample problem. All right, last sample problem. You have 5 gallons of gasoline. It has a mass of 13,750 grams. When burned, how many liters of oxygen gas will also need to be consumed? Again, a problem that's similar, but not identical to your homework. So first thing we got to do is we got to balance this, okay? So let's see here. 8 carbons, I'm going to put 8. 18 hydrogens, 9 times 2 is 18, okay? Now, how many oxygens? We have got 8 times 2, that's 16. 9 times 1 is 9. 16, that's 25. There's no number we could put here to make this 25, all right? Because we could only get even numbers because it's multiplying by O2. So what do we do in this case? We got to double, guys. We got to double. That becomes a 2. That becomes a 16. That becomes an 18. All right, let's see here. Yep, 16, 18. And this becomes a 25. All right. 16 times 2 is 32. 18 times 1 oxygen is 18. That's 50 oxygens on this side. So we would need 25 O2s. All right. Great. Great, great, great. So now, this is the tricky balancing one. All right. My hint to you guys was that's a 2 right there in front. Okay. So hopefully this is helpful to you. All right. So 5 gallons of gasoline has a mass of approximately 13,750 grams. This is our starting amount. All right. 13,750 grams of gasoline. Okay? If you put gallons in here, you won't be able to move forward with that. We can't convert out of gallons. We got to convert from grams. We got to go from grams of this into moles of this. All right? So when we want to get out of grams and into moles, we are going to divide by the molar mass. All right? I'm going to do molar mass of C8H18, aka octane, aka gasoline, 14.22. 14.22. All right. Okay. Oh wait, not 14.2. 114.22. And let me just estimate this to be sure about this. This is 8 hydrogen, so 8 times 12 plus 18 oxygens. Yeah, that checks out. All right. So 14.22 grams per mole. Now, what are we going to be converting into, by the way? We are going to be converting into liters of oxygen. So I'm just going to go ahead down here. I'm going to put liters of O2. All right, I'm skipping to the end. I'm putting the units that I'm going to convert into at the end so that I know where I'm going. All right, this will help me. Okay, so getting out of grams into moles. So 13,750 divided by 114.22. This is 120.4 moles of C8H18, aka gasoline, aka octane, right? That C8, that's why it's called octane, okay? Now, I need to convert 120.4 moles of C8H18. And I need to convert it into, I'm going into oxygen, so I got to convert it into moles of oxygen. Okay, but Mr. Gucci, we want liters of oxygen. You'll get there. You got to get the moles first so you can put the moles of oxygen right here. Okay? We're not there yet. We got to follow the steps. So I want to get out of moles of octane into moles of oxygen. So I want to get out of moles of octane. That goes in the bottom. Let's see, this problem got broken up a little bit. Yeah, here we go. All right. So I want to get out of moles of octane. So moles, C8H18. And I want to get into moles of oxygen. So I'm going to do moles of O2 on top. And now we got to put the numbers that go here. Okay, the number for O2 is, believe it or not, 25. All right, that's a bigger number than you're used to. But then again, these combustion problems usually have weird balancing coefficients. All right, and on the bottom, C8H18, that's going to be 2 because that is the number from, again, the balanced chemical equation. Okay, so we're going to take 120.4 and we're going to multiply it by 25 over 2. And we get 1,505 moles of oxygen gas. 1,505 moles of oxygen gas. Okay? So, our last step, we're going to take 1,505 moles of oxygen gas, and we're going to convert it into liters of oxygen gas. Now, when we're going from moles into liters, we're going to multiply, and we're going to multiply by, well, hey, liters, guys, finally we can use 22.4 liters per mole. So we're taking this number, we're going to multiply it by 22.4, and we're going to get a big number, a big number. Yes, we are going to burn through 33,700 liters of oxygen gas. Guys, this is a real conversion, okay? When you think about how much pollution and damage a car does to the environment, all right? 5 gallons is like half or a third of a tank of gas. And yet, when you burn 5 gallons of gasoline, you consume over 33,000 liters of oxygen. That is a lot of oxygen that trees and algae have to produce. That's oxygen that animals aren't able to breathe to survive. And not only are you taking in oxygen, but you're pumping out almost as much harmful carbon dioxide as well. In fact, in your problem, you're figuring out carbon dioxide. So keep that in mind. These are the practical applications of these problems. 5 gallons of gasoline burns and consumes a whole heck of a lot of oxygen and pumps out a whole heck of a lot of carbon dioxide. All right, and that's just for one car. Multiply it by the millions of cars that we have on the road, the millions of ships out there at sea, including those big container ships. This is what causes greenhouse effects. All right, this is why it's such a problem, because when gasoline and other fossil fuels are burned, they produce a hell of a lot of carbon dioxide and they suck up a hell of a lot of oxygen, okay? So anyways, guys, this is your video. I hope this helped. Next thing I'm going to do is build an answer checker. Bye, guys. Have a good day.